full screen mode, it's not clearing out the browser, but okay. I guess that's the best we can do there. So your PowerShell window is really small, so I would just...
I'll change the font real quick.
Okay, alright. Alright, so I'm going to let you take it from here.
Okay, cool. Thanks a lot, Stacia. And guys, we're going to get started real quick with a quick demo, and I'm just going to run on PowerShell script. That's going to take a while to run, so we're going to kick it off now. Okay. And hang on, let me flip back to PowerPoint. Okay, just to verify, Stacia, you can still see my slides?
Yeah, they're rendering slowly, but yes.
Okay, cool. So hi guys, I'm Joey Danhenny, and thanks for the nice introduction, Stacia. This is Building Perfect SQL Servers Every Time. I'm principal consultant at Denny Cherry and Associates. Just started at the beginning of the year. It's still taking some time to say. And I did hear Stacia say I'm not a BI guy. I do have a certification in BI, just to say, Stacia.
Okay.
So I've been working with databases for over 15 years. One of my most interesting roles, I was principal architect at Comcast Cable. If anybody needs the good customer service line, just let me know. I have it. I talk a lot about database administration, big data, career management.
Hey, Joey, sorry to interrupt. You got a big black box in the middle of your slide. And I'm wondering if there's something...
I wonder if it was the mouse. I moved the mouse away.
No, it's not the mouse. It's like as if you had something that's not being shared, and sometimes it can overlay what is being in your presentation.
The link shows me what you're seeing, and let me move this to the other window.
You know what it was like? It was like where your little picture had been.
Weird, yeah, because it doesn't show me that you're seeing that. But okay.
Oh, there we go. I just cleared it. It just cleared. Well, sort of. Sort of. Okay, let's leave it like that, I suppose.
Okay. So, yeah, I talk about data a lot. I'm a SQL Server MVP. I blog at goodagentony.com. These slides are there. Stacia can share them. And I heard you say you're recording this. This is also recorded from Summit last year. It's one of the ones that are publicly available. If you have any questions, the best place to reach me is on Twitter. I'm at jdanton, which is in the bottom right there. So we're going to talk about what not to do with SQL Server installation. So this session is kind of focused around what the defaults are in SQL Server, how bad they are. Some of them are really, really bad. Some of them are only slightly bad. And then we're going to talk about how to automate that. So I really hate clicking next and waiting and watching. So there's a lot of manual things you have to do to fix some of the defaults in SQL Server. So we're going to focus on how to automate that. And then I'm going to talk about this project we did at Comcast where we built our own private cloud. And I know the term private cloud gets tossed around a lot, but it really was kind of like Azure, where you could select how big of a VM you wanted, if you wanted it to have SQL Server. So we built that process out end to end. And I learned a lot about this and learned some interesting lessons during that. So we're going to talk about that later on in the presentation. So the one thing I want no one to do after this presentation, and it's always my goal, I do a lot of client health checks. And I run into a lot of machines that were just built using the defaults. Someone clicked next a whole bunch. Please don't do that. We'll talk about some of the things that are broken in the installer, and we'll talk about how you can fix them. I'll share some scripts after this that will show you how you can even automate some of these things so that you don't have to go in and manually change things using a GUI or things like that. So what really happens is that bad. As an aside, if you create a VM in Azure using one of the SQL Server templates that Microsoft supplies, it's sad to say that they do a next, yes install of SQL Server. So it clearly isn't breaking their cloud, but it's not going to give you optimal performance to your SQL servers. So we're going to talk about some of the things that you should do. The first one, and by far the first thing I always check when I do a health check on a client server, is to see if max memory has not been set. The default setting for this in SQL Server is 2.1 petabytes, which would be great if we could get 2.1 petabytes in a server. It would go really fast. Unfortunately, the Windows operating system doesn't support nearly that much right now, so we don't have to worry about that, nor can we buy that much memory in a server. So the real problem here is that if this setting is not changed, SQL can try to run away with the memory on the box, which can lead to paging of the Windows operating system. When paging happens, that means pages are getting swapped out from memory into disk, and disk is several orders of magnitude slower. So if SQL Server's buffer cache is suddenly on disk, the performance of your SQL Server is going to drop tremendously. Traditionally, our best practice with this has been to allocate 80% of the memory on a server to your SQL Server instance. So set max memory to 80% of the server. That's still mostly the case. I have this blog link from Jonathan Kahayas at SQL Skills on the bottom. This really changes when you start to get into high memory servers that are larger than, say, my rule of thumb is generally about 128 gig, but because Windows only needs so much memory to run, whereas SQL Server's memory needs are going to be more related to the working set of memory that the data is using. So how big your active data volumes are is going to be how much memory the SQL Server needs. Another thing to note is minimum memory does not really need to be set. You're not really going to break anything with it, but there's some bad information floating on the internet. I know that's shocking, bad information on the internet around setting min and max memory to the same value. And I think a lot of this stemmed from when people first started using virtual machines, that they didn't want to. VMware in particular is pretty aggressive about swapping out memory and over allocating memory so that you can use more memory than is physically available on the server. So in order to protect their database servers against that, a lot of people would try to allocate min and max memory to be the same value. That can lead to some bad behaviors in SQL Server. In books online now, there's actually a reference about not doing that because it leads to strange and unpredictable behaviors. So if you're using a virtualization environment, what you really want to do for your production servers is request that your VMware administrator physically reserve the memory. And what that means is you're going to have a guarantee of that memory being available before your VM comes online on another server. So parallelism. I like this picture because I thought it was a really good description about parallelism. Parallelism gives us a lot of power. We can do bigger queries, particularly in data warehouse and analytic type queries. We want that parallelism so we can parse more data and do aggregations on a much faster basis. But overwhelming parallelism can cause problems with our server because, as we see in this picture, our toll booth lanes are about 20 lanes wide, but we're trying to funnel down into about 8 lanes. That same thing can happen to your SQL server if you didn't configure your parallelism settings correctly. So the two main areas we're going to focus on here, max degree of parallelism is the first. This is the default setting, which is 0, which means SQL Server is going to try to use all available processors if it's doing a parallel query. This will manifest itself. You'll see it if you look in your weight statistics. You'll see a lot of weights around CX packet. And SOS schedule or yield is the other weight you'll see. So these are both CPU-related weights. The typical best practice that I see is for servers greater than 8 CPUs, set max stop to 8. And for servers with less than 8 CPUs, set max stop 0 to n, where n is the number of CPUs per NUMA node. If you're not familiar with NUMA, it stands for non-uniform memory architecture. And most servers we work on now, and probably since about 2008 or so, are NUMA architected. And that just means the servers are going to have each processor in the server, or socket rather, is going to have its own bank of memory. And SQL Server is NUMA aware, so it knows which pages are in block 1, in bank 1, and bank 0. So basically, we wouldn't want to have more cores than, or in one of our sockets in a 2-socket server. Where this gets a little dicey, and these servers are few and far between, but you may run into this if you're using VMs, is what do you do if you have a 2 CPU server? In that case, you probably would set it to 0. Otherwise, it's typically going to be the number of cores in a numer node. The one other exception to this rule is a couple of these Microsoft applications, SharePoint and Dynamics in particular. They want no parallelism in their application, so they recommend you set maxed out to 1. One way you can do this, if you're using the Enterprise Edition of SQL Server, is to use Resource Governor, and it works pretty well with SharePoint Dynamics because they typically come into your database as a common user, so they come in as a standard user. So using Resource Governor, you can limit that user's resource workload to being single-threaded, so only those queries would be affected. And it's actually a pretty good, I've done that for a couple of clients. It's a pretty good way to handle that. The next parallelism thing is cost threshold for parallelism. So this is the cost in SQL Server is based around the time in seconds it took to run a certain query on a server in Redmond about 20 years ago. So that's the basis for cost. And the default setting for cost threshold for parallelism is 5. So if you leave it at 5, you're going to have a lot of very small queries going parallel. That takes us back to our toll booth example. If we have too many things going parallel, we're going to get less overall throughput. So I talked to a bunch of MVPs about what they set this to. And the range varies widely, not too widely. It's basically somewhere between 35 and 50. And people say adjusted later, but most people that I've talked to about it say once you set it to that number, it's pretty good. If you're on a pure data warehouse server, it's probably okay to set it to leave it at 5. I still like to raise it because sometimes on data warehouse servers you still have small queries, or you're doing some metadata queries. But just remember that the default value here is very low and is going to lead to kind of overrunning parallelism on your server. So the model database. If you're not familiar, the model database is something that gives us a template for all future databases that are created. We can override those templatized settings by using T-SQL and issuing a create database statement, but if we just right-click on databases and select new database, it's going to inherit all the settings from the model database. And this gives us a lot of opportunities to tweak with stuff. So like if we want to have a stored procedure in all of our databases, we can put them in model, and whenever you clone a new database, it will be there. But there are also some things that are broken in model out of the box. The initial size of a database is 4 meg, and the initial autogrowth is 1 meg. This is going to lead us to a lot of file system fragmentation because SQL Server is going to have a lot of grow events, so it's going to be constantly growing that file. Just think if you took a 4 megabyte file and grew it by a meg to even a gigabyte, which is 1024 meg, you're going to have all these 1 meg expense spread out all over your disk. So that's not a good thing. Additionally, you're going to have your log file, if you leave it at the default value, is 1 meg, and it's going to grow 10%. 10% is not a lot initially, so 1 meg, 1.1 meg. But eventually, if you think about this could get to exponential growth. If you start talking about, really big log files, you could potentially fill out a drive with the 10% growth. So you're always going to want to change that growth to some chunk of megabytes and not a percentage growth. There really is no right number for what the set model to do. In my demo, I think I set it to 100 meg. It depends. It really depends on the nature of your databases and what you're used to. It's really kind of a trade-off between optimal sizing and how much storage you want to waste by doing this. But definitely change your autogrowth to remove percentage growth. Like I said, the goal here is to remove system fragmentation. I was reading an article from Bob DeWar, who's on the SQL Server customer assistance team today. And he was talking about how, especially even with solid-state drives, even though they're better at doing randomization, if you do poor extent management like this, it can lead to carry-on effects. So you could have all these chunks spread out all over the SSD, and it can lead to some really interesting behaviors in the Windows file system. So just not something you want to do. So change these, just change them to same values and that are more in line with modern data file sizes. So change the model recovery value. Full recovery mode is a really good thing. It's how we get point in time recovery. It's how we support lots of high availability and DR architectures like log shipping and always on availability groups. But I still don't like to set my databases to be in full recovery mode by default. The main reason being, if they're not actively managed databases and somebody's not taking transaction log backups on a regular basis, this can lead to out of control transaction log growth. If you're not familiar with, there's this concept that's internal to the transaction log known as the virtual log file. And too high of a virtual log file count can decrease our insert and update performance in SQL Server because it has to enumerate those VLFs before it makes those kind of changes. So what I like to do here is set the database to simple. Or set model to simple. So all my new databases come in simple. If a database needs to be in full recovery mode, I'll set it there manually. But by default, I kind of like it to be in simple. And once again, if you need a database in full recovery mode, make sure you're setting up transaction log backups on a regular basis. So TempDB, this has always been the subject of a lot of kind of contention for the longest time in the SQL Server community about what was the right number of files to allocate to TempDB. And then at the 2011 PASS Summit, Bob Ward, who's the head of customer support for Microsoft, did a 3-hour presentation on his extensive research on TempDB and TempDB workloads and kind of came up with some numbers for us here. Because there was a lot of legacy talk about how, whether or not it should be one per CPU, one per socket, all these various things. But what Bob came up with is the number of logical processors. So this would be, if you're on a physical server, this would be cores. If you're on a VM, this would be vCPUs, is less than 8. Then the number of TempDB files should be the number of CPUs, but generally speaking, start with 4. So you're always going to want to start with a number 4. Likewise, if your number of logical processors is greater than 8, then set your TempDB files equal to 8. If you observe contention, and you're going to observe this contention in PFS weights typically is the most common one, then you can add files in multiples of 4. Another thing to consider is that as you add files, they should all be the same size and have the same autograph settings. One challenge is, especially if you're doing this online, you could have your initial TempDB file where it's currently growing. So if you're doing this in your servers online, one thing you may want to consider doing is growing the files the new files that you're building and making them a little bit larger than the current TempDB file. And then that way you can grow that file so that they're all the same. SQL Server uses a proportional fill mechanism, so it's going to try to keep all the data files the same percentage full. So if you have one file that's way larger than the others, that's going to mess with that algorithm, and you're going to get hot spotting. So that's something you want to avoid. And 2 trace flags that I recommend using with TempDB. The first one, 1117, is something you kind of need to consider carefully because it's designed to eliminate the problem I just talked about with the hot spotting. What it does is all the files in a file group will grow at the same rate. Even if you have the auto grow configured to override that, it won't do it. Where that could get dicey is if you have other databases that have multiple data files, then you may not want to use that. So just think a little carefully about that one. Trace flag 1118 is something I'd always recommend. It changes the way pages are allocated for TempDB to a better performance model. One thing I'll mention about that, there really is no downside to it. Paul Randall's blogged about it pretty extensively. A lot of trace flags have a kind of you get this benefit, but there's this downside in this other scenario. This one doesn't have that. The one only sort of negative thing I'll say about it is if you're running a newer version of SQL Server, you'll get less of a performance gain. Microsoft changed the way they allocate pages for TempDB in SQL Server 2012 for the better. So this traceback has less benefit if you're in 2012 or 2014. If you're on an older version, you'll probably see a little bit more significant of a benefit there. And here's kind of how that contention works. This would be the look if we only had one TempDB file, and there are these two pages that are of interest, and they're typically living in memory, and it's the PFS page and the SCM page. And here we have 4 users trying to write to TempDB. And if you're not overly familiar with TempDB, just know that SQL Server uses it for everything. It kind of acts like SQL Server's page file, so if SQL Server thinks it can't allocate enough physical memory for a query, it will spill that memory to TempDB and kind of treat that like a page file. Lots of other things, change data capture, read committed snapshot isolation mode, temporary tables, lots of other things use TempDB. So it can be, especially in a busy instance, can be definitely a bottleneck. So if we only have one file, we only have 2 of these pages. So that can be our bottleneck. So remember, spread them out and we'll have less contention. So database mail. I usually see this configured when I do health checks, but it's every now and then I'll see it, but it supports some other things I'm going to talk about that I don't see as frequently configured. This database mail is typically going to be required for notifications or alerts unless you're configuring them external to SQL Server. And the main requirement you need to think about here is an SMTP server. For the demo I just ran, I'm using my Google account. Google has a public SMTP server you can use, but for internal to your company, you're going to want to talk to your Exchange admin and know what your SMTP address is. This was actually one of our more interesting challenges when we built the private cloud at Comcast. We had to register with the SMTP server, so we had to write some PowerShell code that went out, edited a text file whenever a new server got built, and whitelisted the SQL server with the SMTP server. In most shops, it's not going to be that complicated. You're just going to need to get the address and the port of the SMTP server, and you'll be able to send that mail from SQL Server. Which leads us to SQL Server agent alerts. This is a really important feature in my opinion, because it's one of those things that lets you know before your users do when you're starting to have problems. And there's a little bit of like auditing, and sorry about that. There's a little bit of kind of auditing you can do. Like one time I caught one of my junior DBAs doing something completely wrong because he did something and it fired a Sub 17 alert, and I got notified on it. But these are internal alert codes that are within SQL Server. So the ones I like to configure are severity 16 through 25. Severity 16 through 18 tend to be resource-related errors, so it's SQL Server running out of some resource. 19 through 25 tend to be pretty bad errors. Just for a point of reference, those are all errors that in SQL Server 2012 and 2014, if you were on a clustered instance, those would initiate a failover. So those are pretty bad things like process failures, memory read failures. So those are things that you're really going to want to know that happens. Errors 823, 824, and 825 are typically around I/O subsystem failures. So that's when SQL Server can't make a write to disk. Those are also really, really bad. So these are mainly things you're going to want to know about quickly. And you can tie these to actions or pages. So on some of the lower ones, you might want to have some kind of stored procedure, especially if it's something that's repetitive. You could have a stored procedure kickoff to maybe do some cleanup. The one thing I will say, these tend not to be overly noisy, because I don't think there's anything worse you can do from a monitoring perspective than have your alerts be filtered to somebody's email because they're too noisy. The two alerts here that can get a little noisy depending on your server are Sub 16 and Sub 17. I've seen on some systems where those get pretty noisy, so my recommendation would be in that case to turn those down, or even maybe if you're writing your email filters, filter on Sub 16 and Sub 17. But 18 through 25 and 823 through 825, you definitely want to know about. Those are really critical errors. And if they're happening on your servers, it's going to be bad. So backup compression. This is a feature that was introduced in SQL 2008. I know a lot of people still use third-party backup tools. Third-party backup tools like Redgate and Dell Spotlight. Those will actually get you better compression than SQL Server native backup, but A, they cost money, and then B, you kind of have to deal with them. I like to just recommend generally the native compression in SQL Server. This was introduced in SQL 2008. In 2008, it was an Enterprise Edition only feature. In 2008 R2, it moved into Standard Edition and has been there since. Generally speaking, the only trade-off to this feature is it costs you a little bit of CPU, but your backup and restores are going to be a lot faster. Because if we think about it, typically we're either backing up to disk or we're backing up over a network to a network drive. And when we do that, the compression here takes place at the SQL storage engine. So if our database was a terabyte, but it compresses down to 600 gig, we're only sending 600 gig across the network to our, or even to our hard drive. And likewise, when we restore, we're only having to restore 600 gig instead of a terabyte. Where you may run into some political hurdles with this feature is that sometimes, especially if you're in a larger company that has enterprise storage appliances, your storage team may want to use something like a EMC data domain or some kind of backup appliance that does deduplication. And the thing about deduplication that's kind of interesting is deduplication works great on uncompressed database files. However, it doesn't work as well on compressed database files because they've eliminated a lot of duplicate data. So their ratios won't be as good. They'll complain about this, but when they do, the way you kind of fight that argument is to show them your compression number is A, and then B, to show them how long it would take you to restore a database in the event of any sort of a failure. In my testing, when I was working for Comcast on the data domain, our backup times, compressed versus uncompressed, weren't huge. Our sample database was about a terabyte, and it was taking roughly 45 minutes to back up compressed, and it was taking an hour 10 minutes to back up uncompressed. The restore times were where the proof was, though. That my restore, if I restored a compressed database, would only be about an hour and 20 to an hour and 30 minutes. My roughly 3 hours. So needless to say, I went back with that evidence and won that argument. So instant file initialization. We talked a little bit earlier about model and database sizes and how databases grow. If by default, when SQL Server grows a data file, it's going to zero out that file. So if we're growing a file 10 gig and it has to write 10 gigs worth of zeros, it's going to take a while. Well, instant file initialization gives us the ability not to do that. It's something through the Windows operating system where we can have SQL Server just mark the end of the file. So instead of writing all those zeros, it'll just go reach out to the end of the file and write a marker zero there. And this is granted at the Windows level. So there's this, if you look at your local group policy, there's this policy called perform volume maintenance task. That's what you're going to want to use. The way I like to configure this, though, is to work with the Windows team in my organization and have this set for my, whatever the account that's running SQL Server is in my org. So your SQL Server service account, I like to have this set at the Active Directory level so that it's just a group policy so that no matter what SQL Server you build, you know that your service account's going to have this permission to do that. One other thing to note is this only applies to data files. The SQL Server does still zero out transaction log files, and there's no workaround for that. So this will only apply for data files. So the remote dedicated administrator connection. I'm not sure if anyone's ever used the dedicated administrator connection, but the way you use it is to open a database engine connection, and then you specify admin : in your instance name. Where this is really handy is when your server is completely toasted. Adam Mechanic is another SQL Server MVP, gave me some CLR code that will completely thrash the CPU in a server, and I was using it to do some testing, and I realized I had screwed myself up pretty bad. But using the dedicated administrator connection, I was able to get in, because the cool thing about the dedicated administrator connection is that it allows SQL Server to, their SQL Server sets aside a small amount of memory, some CPU resource, and a CPU scheduler, so you can log into a database that on a server that's completely toasted. The only problem with DAC is that we have too many acronyms named DAC in SQL Server. There are about 5 of them now, I think. But B, by default, this is configured only to be used on the server. So you either have to be consoled into the server directly, so right in front of your server in your data center, or have an RDP session to the server. If you've ever tried to launch SSMS in a scenario where the server is at 100% CPU, it's not going to work out too well. So what we're configuring here is the remote dedicated administrator connection, which allows us to pass in those admin credentials remotely from SSMS. So we could be running SSMS local on our desktop, use that admin connection, and take advantage of the extra resources that SQL Server is allocated. And typically, you're just going to use this to kill whatever is killing your server. So maintenance plans. The built-in maintenance plans that SQL Server has don't have a lot of intelligence built into them. They work okay for backups for the most part, but especially when it comes to index maintenance, they kind of fall down. They have limited tuning abilities. I like to recommend this gentleman who's from Sweden named Ola Hallengren. He's built this maintenance solution that's available at ola.hallengren.com. What Ola's plans do is backup, database integrity checks, which are just as important as doing your backups. If you're not doing database integrity checks, that's a good way to lose your job as a DBA, because you could be backing up corrupted databases. It is rather intensive. And then index maintenance. So Ola's script also does index and statistics maintenance. His script should have a lot more intelligence. You can configure fragmentation levels for when you're going to do a reorg of indexes versus rebuilds. You can run statistics or not. You have a little bit more intelligence around the statistics. The other cool thing is it's all T-SQL, so you can look at his code and see exactly what he's doing. Pretty straightforward solution. This is what I implement on most of the servers I work on. There are a couple of other indexing options that a few other people have written that are also pretty good and take the steps even a little further. I like all the solution because it's all in one, and it's pretty straightforward to implement. As part of my build script, I just go out and get the latest version of his code and install it. So patch SQL Server. I like to use this blog spot called SQL Server, their blog called SQLServerBuilds.blogspot.com to find out the latest service pack and cumulative update level. One thing I'll say about this is Microsoft's had a lot of problems recently with quality control, particularly around cumulative updates and them breaking stuff. So what I've been trying to tell people, and initially I started that by saying if a patch or if a service pack or a cumulative update has been out, a week or so, and you haven't read anything about it on the internet about it being horrible and breaking your server, then it's probably safe to apply it. I'm going to amend that and say if you've heard about it for a week and it hasn't been pulled back, it's probably safe to apply it to dev. You probably want to wait about a month to apply it for production, just because some of the bugs I've seen lately have been really nasty. There's in cumulative updates 3 through 5 of SQL 2014, there are some really nasty bugs around how they affect always-on availability groups. So just keep that in mind. Stay on top of this, but don't worry about being on the bleeding edge of it, unless you have something you have a bug that's affecting your operations. But outside of that, you want to stay at least probably one or two CUs behind, and you'll be fine. But you definitely want to stay on top of this, because especially with the new development cycles Microsoft's doing, features are getting added in cumulative updates, so that's something else to think about. And they're making a lot of bug fixes. There's no time like install time to patch, because you'll have to take downtime when you patch in the future, and you can take it when you're building. One nice thing that Microsoft did for us in SQL Server 2012 and up, if you remember in 2008 and below, when we went to install a new server, we had to do this process called slipstream that involved, copying the CU files or the SP files over the initial ISO of the server, and it was really painful. In 2012, we just used this update source parameter, and we can use Windows Update for that. I haven't done that successfully. Or we can use a local UNC path or a local path. And all we do is copy the extracted cumulative updates there, and we can SQL Server install will go get them and apply them to the server. So one other thing to note, I mentioned this a little bit earlier, but all of the above applies to Azure VMs, particularly if you're using the templates that Microsoft supplies. They do a next install. One other thing to note is they install analysis services. I don't mind installing reporting services and integration services alongside a SQL Server engine install, mainly because reporting services doesn't do anything until you configure it. But analysis services, especially if somebody decides to start using it, doesn't run too nicely alongside the engine. So just make note of that. If you're using Azure VMs, you want to think about how to architect them. One of the things you can do is supply your own template, and that may be a better solution for a lot of people. Hey, Stacia, now would be a good time if anybody has any questions. It's kind of a transition point. Okay, cool. So it's also really important to have a standard guides and standard operating procedures. I worked a lot in the pharmaceutical industry, and we were forced to have tons of SOPs. So it's something I got used to, but it's something I kind of carried over to other places in my career. So having a written build standard can really help optimize your solution. There's really no way to automate stuff unless you have a standardized environment. It was something we learned pretty quickly when we were building our private cloud out. If everything's not the same everywhere, it makes automation impossible. So one of the things that you need to consider is drive locations. So what you're going to call your data drive, what you're going to call your transaction log drives, even how you're going to lay those out, whether they're going to be separate physical devices, whether they're going to be one drive, different devices. So there are best practices around that, but a lot of it depends on your SAN and its configuration. One thing I'd like to use there is, if you're not familiar with the concept of volume mount points in Windows, this is where you can mount a drive under a drive letter, so you can have E:\data be its own drive, but you're not actually giving it a new letter. It just keeps things a little cleaner and easier to understand. One thing I did, and this probably only really matters if you're in a very large company, is using standard volume sizes. We were way over allocated in a lot of our volumes, and enterprise storage is still pretty expensive. So in an effort to reduce that, I made our default volume sizes a lot smaller than they were. If a database needed more space, obviously we'd give it to it, but by default, I kind of went with a conservative approach there. Storage here is kind of an interesting one, especially with modern storage architectures that have tiers, so like solid state, fast disk, and then dense slow disk. You're going to want to configure policies. One example of that might be you don't want your transaction logs to go to solid state because they're not going to see a real performance benefit from solid state storage. You might want to always have tempdb in solid state storage because it's doing a lot of random I/O and it's going to see it. Additions, settings, and builds. So what versions of SQL Server you support, whether you support a mix of standard and enterprise edition, and then what settings you apply across those. One thing with the private cloud we tried to do is limit the number of versions we supported. because the number of versions that you support is going to increase the number of templates you have. The more templates you have, the more maintenance you're going to have to do when it comes to patches. Specify an OS. I really like to force applications that are using SQL Server to run at least their SQL Server on the latest version of the Windows operating system. There have been a lot of benefits in the 2012 and 2012 RT releases. And every now and then you'll have a vendor who says, oh, we only support running SQL Server on Windows 2003. If a vendor says that, they're probably lying to you, or they haven't tested, so challenge them on it. Because almost every application I've ever worked on doesn't really care what version of Windows its database is running on. HA and DR options, so this kind of ties into having a DR plan. But basically, set your tiers and what high availability and disaster recovery options you're going to go with. And then finally, security. Who's going to get access to your databases? And revisit these standards every 6 months. It used to be something you could kind of leave on the shelf until the next version of SQL Server came out. But especially in the cloud world, things change so fast now. You may have to check on these on a regular basis. Standard hardware is really good. We have the advantage at the cable company of buying 1,000 servers at a time. So I always knew what I was going to run on. I know that's not realistic for like 99% of companies. But if you can consistently buy the same brand of hardware, at least you mostly know what your firmware is going to be. And work with your sysadmin teams for guidance on an operating system level. Some of these things can be helped along by group policy and a couple of other Windows things we can do. So one other thing to note is there's always going to be exceptions. So you're never not going to have exceptions whenever you have any standards process. Don't sweat them. You just have to know that they're going to be there and know that it's not that big a deal. You don't have to remediate everything, but you do want to keep track of them. So you want to know what the exceptions are. We'll talk about this in a few slides, but you're going to want to have a monitoring process. Once you have your standards in place, you're going to want to monitor for compliance with your standards, and there's a couple of ways you can do that, and we'll talk about that. So process automation. I'm actually in the process. I'm in the process, no pun intended, of writing a new presentation that's going to be all around DBA automation and various things you can automate. This has been one of my favorite things to do because I'm lazy. If you do a process more than a couple of times, automate it. Learn code, learn how it works under the hood, and automate it. What we're focusing on here is just our build automation process. But there are a lot of other processes you can automate. You can automate index maintenance. You can automate all sorts of things to happen, not even scheduled. And some of this even ties a little bit into machine learning. I think our future is going to be something around self-tuning databases, where we detect certain conditions and then take some certain other action. But one of the things, so we didn't just automate the install of SQL Server, as we'll see in the demo. We automated all the post-install configuration, and a lot of that stuff is dynamic based on the configuration of the VM I'm installing to. So just think about that, and think about what processes in your job you have to do on a regular basis are painful, that you don't like to do, or where you have to click a mouse way too many times, and then look at how you can automate those. The key to our automation was really what we called the infrastructure server. You don't always have to have these, and we kind of rolled our own. We built our own performance data warehouse, but SQL Server has something built in called Central Management Server. It doesn't scale well past 500 servers, and that's why we built our own. But most shops I know have less than 500 servers. So if you're in that scenario, check out Central Management Server. It can be really good for this. But in addition to just collecting performance data and metadata about our databases, we stored our installation files there, so we drove all of our installs from those servers. We had one of these servers in each of our data centers, or at least a copy of the data using DFS, so we could keep our installs pretty fast. And we also set it as the update source, so we kept the install media there and we kept the update. We used it for a lot of metadata. So we kept all our application owner stuff there. We kept which DBAs were responsible for what. We even kept application passwords here, and this is why the server should be very secure. We had the application passwords very locked down. They were encrypted in the table they were in. But this is one of those servers that really no one except your DBA team and probably you can't really keep your domain admins away from anything. But this is something that should be locked down. But this, if you build out something like this, it can give you a lot of power and a lot of insight into your environment. One of the things I really liked about having it was I could trend performance of our database servers over time because we collected all of our performance data here. I also put all my compliance data there as well. So I built a lot of reporting through SCCM and going out to other servers to grab the data, and I use that as the hub for our environment. So with virtual machines, you can really take advantage of a lot of this stuff, and it can get a little complicated, and I've taken two approaches. There's one that I did that was good, there was one I did that was really bad. When we started with this, I had my concerns about cloning SQL servers and how SQL Server would handle the rename. In the time since I started this, I've learned a lot about that process. Basically, renaming SQL Server is not a big deal. We first built our private cloud. We installed SQL Server at runtime, which was a really messy process. It extended the build time of our VMs to around 45 minutes, and it broke about half the time. Breaking half the time is not a good thing. So what we ended up doing was going with a baseline install for SQL Server. There's a couple of things you have to do here. You have SQL Server installed on a VM, plain Jane install that isn't joined to the domain. At your build process, that server is going to get joined to the domain. Well, it's going to have a couple of things happen. It's going to have sysprep run on it, which will clear out all the GUIDs. Then it's going to get renamed, and then it's going to get joined to the domain. After that, SQL Server is actually pretty happy with that, except SQL Server thinks its name is the old server name. So what you'll have to do is run sp drop server and sp added server to give it the new server name. And that's you can automate that at build time. One thing to note, you may want a couple of different settings, and I noticed recently Microsoft has added some different kinds of VMs to the Azure Mart. Obviously, OLTP and OLAP and data warehouse servers may have different kinds of requirements around memory and drive configuration. So you may want to have those different templates. Like I mentioned earlier, though, the one challenge to that is that you have to maintain those templates. So as CUs come out and as Windows updates happen, you have to worry about the maintenance of those templates. So those are just some concerns around that. So one thing you can even do is like kind of optimize that post install. So if you can do something consistent, maybe based on a server name, if you can create that logic, you can even automate that. So I always say trust but verify. So you have your standards and you've automated your process, but it's still nice to be able to enforce it. So what we did was we leveraged our infrastructure server. We ran a bunch of consistent reports. So every day I generated a list of all of our SQL servers that were in our environment. I ran a general health check against each of them, and I brought back all of the failing values to my central server, so I could see what was failing and what was out of compliance. You can even take this a step further, and if you have your exceptions documented and you have them in a table, you can take your exceptions out of that, and you can get to a real compliance percentage. This was one of those things that was somewhat useful for us as database people, because we could catch outliers, and I once caught a server with like 875,000 VLS because nobody was taking log backups. But more importantly, it made my manager and his manager really happy because I built some really pretty reports showcasing what our compliance level looked like and how we were improving on it over time. So this was one of those things that was working in corporate IT. It was a really easy goal to set for myself because I knew it would be pretty easy to fix, and I knew what our baseline numbers were, that we were going to improve our compliance by 25% over the year. That was kind of a no-brainer. So this was kind of a neat solution. So we leveraged all that metadata we had to do that. So we built out a private cloud as well. I talked a little bit about it throughout the presentation, but I'm working with another client on this at the moment, and it's kind of an interesting scenario. You really have to make decisions for 80% of your environment. Yeah, you're going to have those servers that are outliers that are huge and need, a terabyte of physical RAM. But when you're sizing, and if you're building a private cloud, I'm just assuming you're using a virtual environment, you're sizing out what your VM should be. You're going to want to make the decisions around what the 80% of your environment looks like. Don't worry about the outliers. Automating the SQL Server install isn't that bad. I'll show you the code we use for that upcoming when we get to the demo. However, Windows is a little trickier. There's a lot of things like joining domains and figuring out whether or not how we should create drives. That took a lot of logic, and that took a lot of time and a lot of hard hours. SQL Server itself was pretty straightforward. But the biggest challenges we had really were around management and sprawl issues other than technical ones, because we typically, when you got a traditional request from a database server, it was a formal request, it was an application team, and you knew who they were. In this case, we weren't able to pass that metadata of who was requesting the server all the way through, or what application was requesting the server. We did automate adding it to our monitoring, but we just didn't always know who requested it. Another thing was granting access. We had people requesting VMs, and by default, they'd get admin access to the VM, which was okay. But at first, I really didn't want to grant them SA access to SQL Server. And then eventually I relented because I realized most of these weren't production boxes, and it was people who were wanting to do development. So those kind of management issues are really the tricky stuff we had to deal with. And this is kind of how our interface looked like. We had a user interface on our intranet site. We had what was known as a service management layer, and these are like System Center has a component like this. If you're using VMware, there's something called vCloud Director. And all this does is translates the user request to build, say, a VM with two CPUs and 16 gig of RAM, translates it into code that gets sent to the VM layer to build out that VM. And then on the back end, we had pretty hefty infrastructure. We had, an enterprise class SAN with some pretty beefy servers in front of it that had a ton of memory, so we could scale that. It was a pretty nice solution. It was one of the more challenging projects I've done in my career, but I had a nice sense of accomplishment after. So the lessons we learned during this process were really to capture the owner info. That was the biggest part of the private cloud that was a problem. And acknowledging that we had to release a little bit of control, because not everybody was going to do everything exactly the way we would have as a DBA team. And those are kind of some of the challenges around doing that kind of a project, is that not everybody's a DBA, not everybody's going to do everything you want them to do, and sometimes they're going to write bad queries or do bad practices, and you just kind of have to let it go. So let me flip back over to the demo.
Of course, we're still in here, so it's like Joey left us, right? But our little black square went away.
Right in the middle of the lecture.
Yeah. Okay, Joey. Joey?
Hey, Stacia, can you hear me? Because I think I killed the link.
Yeah, I hear you. Can you hear me? I hear you. Hello, hello.
Stacia?
Yes, I hear you. Hello, hello. Let's see. Yes.
Okay, thanks. I'm back.
Can you hear me?
Sorry about that, guys. So here's the VM. Here's the VM we were working on.
That thing showed up again. We had our little black box went away, but now it's here again.
Make sure. One second. Hey Stacia, I can't see my chat window. Can you text me if you can see this VM? Because I'm not 100% sure you can.
Can you hear me at all?
Okay, bad autocorrect in the text. Okay, so here we're looking at the PowerShell script that ran, or actually the batch script that ran, and let's take a look at what I did. So I was in C temp and I called a couple of things. So where we started was this Sandlin SQL install batch file, and this is pretty straightforward. We're just calling setup.exe with a configuration file. And then I'm calling after that, and we'll walk through the configuration file in a second. Then we call PowerShell, and all I'm doing in this PowerShell script is going out to Ola Hallengren's website and grabbing his SQL Server file. This step could be optional, and you could just have it saved locally. Okay. The next thing we're doing is calling SQL CMD. In the past, you could actually just call SQL CMD because it would be in the path after you installed. Now it's no longer the case. So we're doing -e, which means that you're connecting to the local server, and then using a -i, which is an input file. So we're calling SQL best practices run once.sql. We'll walk through that in Management Studio in a second. In the script we generated in this ola.ps1 file. So let's take a look at our configuration file here. The first thing we're doing is calling our update source. So I'm using a local update source here. This is c:/SQL updates. The next thing we're going to do is start the database path. So a lot of people like to put SQL Server on the D drive, separate from Windows. In this case, it's my VM, so I'm just using C. We can do that. Here we're specifying where we want to install the system databases. Once again, I would definitely not recommend doing this on C. This is really just for demo. TempDB we're also specifying, so we could put that on its own drive. Database log files, and then user databases. Likewise for backup. We specify an SA password here. So one of the things we did when we were doing the private cloud build was we read this file to ctemp, we ran our build process, and then we deleted it just so the passwords were no longer on the server. Here are the account passwords. Likewise, this is kind of a security problem, so that's why we had it. This would exist in our template, and then we delete the file. Quiet simple allows us to see the installation process take place, but doesn't require any input. You could really run that as just quiet, which would be a completely silent install. Configuring our agent startup types. Microsoft Legal makes us accept the SQL Server licensing terms. And then here's where we're just specifying all the features that we're installing. So I install the engine and integration services, the SSMS. So these are just kind of standard features, and you can generate one of these INI files from a SQL Server install. These are all basically just the options that you check off. So here's where you specify if you want to send error reporting to Microsoft or a feature usage. So these I typically allocate to false in most of my installs. So that's where we go. We specify instance name here. So here we're just going to go with the default name, so MS SQL Server. And then next we're going to specify our agent account name and startup type for integration services. The rest of this I have commented out. This is just analysis services. I don't have this configured on this machine. And then here we're specifying our SQL Server service account and who we'd like to be the system administrator. So if we look here, I have corp/Joey as a system administrator. Corp/SQL admin is my service account. Additionally, we can add the current user as SQL Server admin. Here I'm using mixed mode authentication. The default is going to be Windows. And then reporting services, configuration, and service accounts if I were installing it. I didn't do that as part of this install. So let's go over to SSMS. So one thing you'll note is up here, the build number is 12.0.2456, which is the current, I think that's CU5 of SQL Server. And if we look at system databases here, and I go down to TempDB, and I select properties, I see that I have 4 matching data files created. We'll show the script that did this in a second. Hang on, I'll zoom in a second, Stacia. I didn't know that I have it here, but I can grab it. Give me a second. Hey, Stacia, if you have any questions at this point, I can take them on downloading Zoom it.
Yeah, you have questions? Can you change the font size?
No, I already know that. So some of the things that meant is we can't change the font size, but we can get an application to Zoom in, so that's what these two files are right now. But, there's other questions. So,
So here's the script that we ran as our post install. Sorry about that. Hang on 1 second. So here's our post install script. The first thing we did here was going to be to configure database mail and to turn it on. The next thing we're going to do is change the model size. And here I used 100 meg and file growth of 100 meg for both the model database and the model log. Like I mentioned in the presentation, this isn't the ideal size for everything. It's a good size for my stuff for a demo. Next, I went to MSDB, and I set it to 1024. MSDB actually stores some data, especially around DB mail and alerting. So I grew that to 1024, and I also modified its log file. And then finally, I did master as well. You don't necessarily have to go back in and fix these, but I like to, if for nothing else, in my compliance scripts, I check to see if there are any databases that are set to the default settings, and it's something I like to alert on. The next thing I'm doing here is writing to the registry. These are the trace flags that I'm setting. Unfortunately, there's not a great way to programmatically set trace flags. One of the things you can do is set a trigger that will run on startup and turn them on. And I kind of go back and forth between writing to the registry and writing to here as to what I think is the better approach of doing that. So that is always a little bit of a challenge. But here I'm writing to the registry. I'm turning on 3 trace flags. The 2 aforementioned ones around tempdb, and then finally T3226, which is a trace flag that turns off transaction log backup successful messages. So that means you won't have your error log filled with those transaction log messages. So the next thing I'm going to do is configure tempdb. I use a bit of dynamic SQL, and I grab some information from sysdm OS volume stats to showcase how big of a drive there is. You can see that code here. It's commented at because I don't want to blow up my VM, but I just set it to 5. But by default, this is going to go in and calculate how big my tempdb file should be and set them all to the same size. The next couple of things we're going to do is set min and max memory. I do set min memory into a gig, just kind of out of habit. It doesn't really need to be there. And then here I'm setting the max memory to 80% of what the physical memory looks like. So I'm grabbing the physical memory again from sys.dm OS sysinfo. And likewise, I'm going to set max CPU count based on the number of CPUs. I have this logic, and it works great in a virtual environment. What I did have this configured for is a physical environment. I need to work on writing some code to go ahead and figure out how many CPUs are in a NUMA node to handle that for a physical environment, but I just haven't had a chance to do that yet. Then the next thing I'm going to do is just go ahead and set up the email. So right now I'm setting this up to go to my Gmail account, mainly because of the SMTP that I have available. Sorry about that. So this is just creating a system mail account. And here I send myself a test email that I always like to do. And then here's where I configure all my severity alerts. So SEV 16 through 17, these are just SQL agent jobs. We do this through MSDB. And then finally, the last thing I do at the end of this, after these are all created, is I send myself a test severity 16, and I log it. And if I go to my email, I should see that I have I'll have two emails from this server. So I have two emails from the server in my email box. One tells me that the test mail was sent, and then one that tells me that the server was finished building. So in summary, do this stuff. Automate your builds. I mean, I'll have Stacia give you guys the PowerPoints and the code that I was showing. But this is pretty straightforward to do from an automation perspective, to automate builds. And your servers will love you, and you can actually spend less time installing SQL Server and more time working on fun things like performance tuning and troubleshooting other problems. My Twitter handle is jdanton. You can email me at jdanton1@yahoo.com. If anyone has any questions, feel free to chime in.
Joey, can you hear us yet?
Yeah, you can't hear, but I can text him.
I just want to check if this will work with the common cell
Okay.
or just some fixes.
He said yes, all versions. Yeah,
Yeah, so Stacia said if this will work with SQL 2012, this will work with all versions. You can probably do this. You could probably do this on SQL 7, I think. Some of the automation stuff, like setting memory, might not work because some of those DMVs weren't available in very old versions. Somebody asked the question about performance advantage using virtual servers. That's really a hard question to answer. Virtual servers are always going to be a little bit slower. In an optimal configuration, it's somewhere around 1 to 2% penalty, just from some of the CPU scheduling that VMware has. Typically, virtual servers are more used for flexibility and convenience more so than pure performance, but that does not mean that you can't configure them in a manner that they're going to perform very well.
Just to expand on that, you can put a data warehouse in VM, it's like a one-to-one, you'll most likely lose the 100%. But you can do a data warehouse in VM. That's
Performance difference between VMs and Azure versus Amazon. Good question. A lot of that's really going to depend on your configuration. And in all honesty, it's just given the nature of the cloud, it's going to depend on who the neighbors of your VM are. I know some people that have written, actually Netflix did this, they wrote some code to baseline the performance of a new VM they created at Amazon, and if it didn't have the performance characteristics they were expecting, they'd actually just kill it and create a new one until they got one that had the right performance. There are a lot of factors at play in the cloud, especially around configuration. Azure was pretty far behind Amazon on storage performance up until around December. Microsoft introduced some solid-state storage options that pretty much brought storage performance on par, but you're having to pay for them. I think the baseline storage performance at Amazon is probably a little bit better. I think these are all going to be short-term things. I think Microsoft and Amazon are basically going to be on par with each other because there's only so many ways you can configure servers. You can configure infrastructure to get a certain performance level. So I think they're both going to reach kind of an equilibrium in the near future. All right, thanks everyone, and have a good night.
Thank you, Joey.